So hello guys, this can be our second video. So this contest has been delayed by 10 minutes. I don't know why. I started recording and suddenly this shown me that still 10 minutes left. So I told some of the things in the last videos that the last video which I recorded but didn't able to post as the contest didn't started in that video. So the thing is that I will be solving the questions in front of you while contest is going on. After I have finished solving the problem um, as I want, I will explain you how I solved the problems. Um, so just skip to the last part of the video. I will explain every solution. If you don't understand in between the contest, this is a div 3 contest, so I think most of the questions will be straightforward. And this is a 2.5 hour contest. I am not going to get till that. I will be like solving the problems till 9:15. I will pause the video and then I will come back and explain you how I solved the problems. So just stay tuned. We are not watching live. Right? So, and I'm also using Vim to solve problem. I use WSL2 and that's all. Let's begin. 5, 4, 3, 2, 1. Oh my God. Oh. Okay. The dynamic login system for Keen Devin discovered that most users use weak password. To resolve this issue, he posed the following condition: depend on two variable k and x for all password. Each password is a string s of length n. Satisfying these properties, s use only the first k lowercase letters of English alphabet. Okay. For each pair of indices I less than j, such that j minus I is divisible by x. Okay, the letter si and sj are different. Okay, find the smallest integer x such that no valid string of length n exists. Okay. Okay, we have to just multiply it by 26, I think, and we will be able to get it. Okay, divisible by x. I think I'm correct. Okay, we have to multiply it by just k and output. I think kx plus 1 is the answer. It's quite straightforward. So this is my template and int k comma x. I don't know in which order they are getting. Just have to. I think it is straightforward, but I think just the thing is this one. How is it coming? Actually, I don't know. So is it running properly? 376. 376, right. Okay, we can write it here also. 376. Let me submit it. Okay, we are. I hope it will get submitted. Yeah, it is getting submitted. So let's move to the next problem. Problems. I think I'm very slow today because I think I'm explaining. That's why I don't know actually. I'm not explaining after I am a medalist. In order to get a class, X must take the crowded elevator to many floors in a certain order because he is a hacker. He can skip visiting up to one floor without the other person knowing. His time taken is sum of the absolute difference between consecutive floor. Number Find the minimum time taken given that he can skip up to one floor. More formally, okay. Teacher choose okay to erase such that we have just it's a simple question I think. So it gets submitted. Yeah, it's accepted. You're seeing my setup. It's really cool. We can just solve this by pre-computation, I think. Uh, like we can calculate for all. Okay. We can no, not answer. We should have difference which equals to 0 for int I equals to 1 I less than ni plus plus. We can just add the difference of these two number in this. Okay, we have to take the absolute value. I think we have to take the absolute. What is it saying? No, this is not this. This. Yeah, we have to take the absolute value. Minus ai minus 1. So this is the whole difference, and now what we have to do, we just have to minimize it by removing the consecutive difference. We can skip what we can skip. We can skip if k can be 1 also. Okay, and k can be n also. So in both of these we will not get a better answer because if we choose 2, automatically if we are choosing 1 will be covered. It's quite intuitive if you are getting, but I have to solve this problem early, so I will just write this solution. Maybe I will explain at the end of this video. Difference cannot answer the total difference minus absolute of a I minus a I minus 1 minus absolute of a I plus 1 minus a I hope this should work, and this will work. It's a diff 3 problem. 11 to 12. 11 to 12. Oh my god, the output is not same. difference. 11, it's not 11, it's 33. 33. We have to do one thing, but by that also, oh, I am taking max. I should take min. And also we have to add the absolute difference of a I plus 1, okay, minus a I minus 1. Okay, this will, what this will do, move this. Okay, we in starting also, my assumption was wrong. Because of this we have to this do this these are the condition when we are removing the last element or the first element. We have to consider them. 11 to 12, I'm sorry, it's correct. We just submit it. Let's move to the third question. Black Slash worked too hard and started dreaming about numbers. Solve the following tasks in the array. You are given an array a1, a2 to an. In one operation, you choose index I and an integer x, which is at least k. Okay, the x will be greater than equal to k, and set ai to ai modulo x. Where you and okay, your goal is to make all elements of the array identical among all positive integer k. Determine the maximum k for which there exists a finite sequence of above operation that make all array elements equal. It's got submitted or not. It's in the queue. You can check it here as well. Yeah, it's in the queue. So where u mod v denotes the remainder of dividing u by v. Okay, that is no use. Determine maximum k for which there exists a finite sequence of above operation that makes all array. We have to tell the maximum k for which this will happen. I think it's quite straightforward, but print the inclusion maximum integer k such that is will make element identical using any number of such modulo x restricted. So if we choose any x, we will make the elements from 0 to x minus 1. We can make this. We can do this. So if we just can we apply binary search here? It is asking for maximum k. It got submitted, the B question. So we will open C question. if we can choose any x greater than equal to k, then what values we can get? Or we can take ai to which value? So if ai is less than k, we cannot do anything about it. But if it is greater, we can do something. We can make it 0 to k minus 1, whatever we want. Is it so? Yeah, that's true. So what's the issue here? No, we can't. We can only make it ai if ai minus k is less than k, then we can not make it of any value till k minus 1. We can only make it ai minus k max, or we can write it 0 to ai minus k. So we can just check. I think binary search, I think it will be solved by binary search, I think so. I don't have any proof or anything. I'm just going to write it. K can be 0. But we will not be able to take the modulo. K should be 1. For 1 it will always be possible, and K will go till max element. Sorry. Alright, we just write the check function. Well, we will be -1, and like I'm going to set val as any integer which is if I is less than k, So for all I in a, if I is less than k and val is not equal to I, return false. Like if it is less than k, then it should be equal to the value we are getting before, because we cannot make it we cannot change its value. So yeah, that's the case. And minimum will always be this, and maximum will be equals to in the starting will be k minus 1. if if I is less than no, not I minus k is less than max equals to I minus k, else no, if I minus k becomes greater than max, then it is not possible, so we will return false. Return true. I don't know what I'm doing, but I think it will be correct. Answer will be equal to m. This check function is correct, then it is 5 to 6. K was not declared. Okay. I think this should work. What's wrong with this program? This file is I think I did something wrong before. We have to just input n. K. Here it should be k. What am I doing? Again, some mistake. And then here to n. This is not verifying it. Why isn't it so? 4 6 what will. If this is maximum, then this return false. What the wrong? Okay. For 6, if we check the, like, it is giving correct answer till 5 for the test case 3, but in 6 test case it is failing. Why is it failing? We have to check that. So like for 6, this okay, the only value is less than 6 is 5. Okay, the val will be 5, and then if we go here, it will be 5 only. Max will also be 5. So none of the value other than 5 is equal to uh, other than 5 is less than k, so this will not be true for any of the numbers. Then we will check this. So this value is 5, and if anyone is less than that, which is no one, so why is it returning false for that? It should return true. Okay, we have to use that. it is returning false. Why is it returning false? Max became -1. But okay. Sorry. This. Yeah, that's true now. We should submit this. It took a lot of time. It was a easy problem, but I don't know why I was not able to like debug it. Sometimes it happens. So let's move to the question D, which is black slicks. Okay, it is running. Penguins are civilized creatures that communicate using permutations for a given integer n. Consider permutation of an array is equal to 0 to 2 to the power n minus 1, defined as summation of the number of okay, we are taking the end of every upcoming permutation and just outputting the pop count of the end. I can see 0 is also there. So if you take n of the 0, all will become 0. But I think something wrong with this. Okay, they are starting with they are starting with I. Okay, like till I. No, so that is also true then. Okay, summation of the pop count. Yes. P0 is 0. But how is it happening? Is it submitted or not? Running on test 5. It will get submitted, I think. See, it shows the, yeah, some accepted. If we check here, it also says accepted. So let's come to this problem. A permutation is squared if maximum is P, find the lexicon minimal squared. What they are saying, okay, where is the number of 1 bits in the binary of Z. Okay, okay. A permutation is considered sacred if it maximizes SP. Find the lexicographically minimal sacred permutation. Okay, we have to arrange this such that this happens. Okay, so so we just have to put 0 at the end. This is fixed, and the string which is all of 1 should be in the front, so that it minimizes the loss of ones. So I think for better understanding, you should have. Okay. Initially, we should have all 1, which we can have. Whatever it will be there, we can have it. Okay. and until 16. Okay, only single number will have this 1 1 1 1 1. Then we will have a number which will have 1 1 1 less 1 than that, then so on. So, hmm. And we'll always minimize the number of bits we have. But we have to output the permutation string. Okay, that is like simple question. I think if we have to output the string of a permutation only, we can just choose, like if we have n equals to 3, so we will have 7, then 7, then because all bit are set in 7, then we can have, oh, it's an easy question. For for any n, we just have to output n 2 to the power n minus 1, then 2 to the power n minus 1 minus 1, and so on, and other elements. This will this will solve our question. If you see, it is quite intuitive because we will not have all set bits in all the numbers. Like for 7 we will have 3 bits set, and then after 7 it will be 3 where we have 2 bits set, so we have to lose a single bit in each operation. This will be the most beneficial and most like greedily we will choose greedily, but this will give us the we can have like vector visited. We can just output sorry, we should save this in ending number. No. I like to make my code arranged. If not visited, then see out. Okay. Okay, 1 1 0. That is correct. 3 1. Oh my God, it is correct. Like, it is exact same actually. I didn't expected that. I hope you understand how I came to that logic. Let's solve the next problem. It's in the queue. After falling to pick up a girl, due to high charisma, he is now in charge of drawing border of n voting district of his country. I want to see the accepted D. Then I will be able to read that question properly. It's just with me. Okay, after failing to pick up a girl D Boringen sequence of fixed length bit strings, Blackster has turned his attention towards politics. Due to his high charisma, he is now in charge of drawing borders for n voting district of his country. In Black country, there are X voters for Party A and Y voter for Party B. Using his amazing drawing skills, he can allocate voter from a party into any district of his choice. Okay. His history with bitstring has led him to wonder if he can allocate voters such that the winner of each district follows a certain bitstring pattern. To avoid suspicion, he must also allocate at least PI voter into each district. Tell him if it is possible. Formally, you have given a binary string S of length n, an array P of length n, and two string x and y. You want to determine whether there exists two array of non-negative integer a and b of length n that satisfy the following condition. Okay. This is like I'm not able to understand this question. Oh, wrong answer on test case 2. So something is wrong with our what it can be. But getting a wrong test case and is very heartbreaking. Where it can go wrong. Lexicographically minimal. Lexicographically minimal. It is ensuring that I think it will give us the lexicographically minimal. Is it so? Like 6 is also have 2 bits set, but 3 is less than 6. Outputting 3 will give us see lesser. Of course, so it is taking care of it. Like, but for higher, just If you take this, it will be 3. Take this, it will be 5. Take this, it will be, one sec. This will give us the best solution or not. Here our n will be 7, okay, which will give us 3 pop count. After this it will become 2, which will give us 2. This is the maximum we can get here, and 3 will be the least possible value which will give us, and after that 1 will be the least possible value which can give us. After that 0, and then 2, 4, 5, 6. We don't care actually. After once the 0 came, nothing matters. But still, we can have 5, which will give us better answer after 1. All the odd, all the odd integers will give us better answer. But is it only true for 1? Is it possible for 3 also? Got it. This is a bit masking question. So what we can just do, we can just put integers which will give us 3 after taking n with 3 in an vector, sort them and output them. We don't have to sort them, it will be sorted only. So yeah, it will give us the right answer. We can just make it map int vector of int. No. This condition checks the bits are set in that number also, which are set in this number, and we will just push this into its array. I hope this will not give me any compilation error. I think this should work. Okay, we have to do this in the reverse. So we can just do one thing. We can just put this negative. Yeah, this will work. This should get submitted. Yeah, I knew that. So uh, I'm I'm stopping this contest here. Maybe I will come back and solve questions. Maybe. So let's see. So yeah, I'm back. So let's move to the fifth question. The contest is still running. Only 40 minutes are left. I think maybe I will be able to solve the fifth question as well. So let's read it. Actually, we already read it. I don't know. Oh, that means it's very tough to understand this. Okay, okay. Oh, AI denotes the number of voters of X in each district, and BI denotes the number of voters of Y in each district. And there should be at least PI voters in each district. And if SI equals to 0, we have to make AI greater than BI. If SI equals to 1, then we have to make BI greater than AI. And we have to tell is it possible or not. So in the if anyone have less value, okay, I should open the. Suppose if x is less than y, then we need at least and si equals to when will it si equals to 0 we need at least pi2 plus 1 should be written as ai should be greater than equal to this. And at the end, if we get any remaining element, we will just add them to the district where, like, if we have extra x, then we will just add it to any si equals to 0, and same we will do for y, just where si is equals to 1. So okay, so we have to just do that. So we have to just output yes or no. So how will we verify this? This is just tool if we have to output the solution for this. But if we have to just verify, we can easily solve this. But how? This shows that these are the least values that x and y can have. So x and y should be greater than this x expected and y expected, which will be the sum of these values. Okay, so we should just solve. nxy and then string. Okay, and x expected equals to 0, and we can name them y expected, x expected, or we can just that name them as x min, y min. So we will just traverse. One more thing is there, that there should be at least one si equals to 0 and si equals to 1 if x is greater than 0. But x and y will always be greater than 0, so we need at least one si. Okay, we just actually we don't need it. Just we have to take care of the extras. do one thing here. Whatever is the remaining, we can just sub- subtract it from y, because this is true. We can just yes. I don't know whether the solution for this is correct or not. Yes, no, yes, yes. Okay. In fourth test case, there should be no, but it is showing yes. Okay, there is one more thing, that if you increase the number in any village, you have to decrease the number of other in that village. Okay, so the sum of both of them should be 0. I think so. I thought of it actually. The sum should not be 0. Maybe, maybe not. If you have to increase any one from x, okay, this condition is not good actually. This is the minimum expectation, like like we have to have at least this much, but if we have excess amount, so what we can do, it not work actually. Just run and check. Same answer, yeah. What is happening in the fourth test case? What is the fourth test case actually? Okay, 4, 20, this one. Y is winning all over, so you cannot manage X anywhere, like if you have extra of them. Okay, at least pi should be there. You can have as much as we want, so at least pi should be there. So in all of this, this 2 will be divided by 2 and added by 1, so all will be 2, 2, 2, 2, 2, and will be added only in y. The y expected will be 4 times 2 is 8, and 8 y is greater than x expected is 0, and x is 23. So obviously x is larger, but we don't have a way to manage this x. I think this is good for this contest. Let me explain you all the solutions and just um, leave this contest. I'm done with this. So okay, first question, second question, third question, and fourth question. So first question was pretty easy. We have to just multiply and add 1, because if we are trying to make alphabets different, and we can use only, so this is the first question. So if we assign any value to any index I, we have to assign different value to I plus x, I plus 2x, I plus 3x for all I. So what does it tell? That we can have only how many? X minus 1, k minus 1 such indexes, and we will multiply it by x. And we will add x minus 1, because this will be happening with all the indices if from 1 to x minus 1, or x, yeah, 1 to x, all will be different. So we have calculated for first index according to first indices, but we have to calculate according to the last x. So we can just do that before. So after this we will have this much indices, and that's why we have to add plus 1. Now I get it, why we are adding plus 1. Actually we are not outputting this, we are outputting this. If you understand this formula, you will be understanding the question, what it is saying. So let's move to the next question, what it is. Okay, we have to remove this is a pretty straightforward question, implementation based. So what we did here is that we just removed the number and checked, like if we have a1 a1 minus a2 plus a2 minus a3 and so on. What will change if we remove any AI? So the change will be that previously we had something we were adding, and then we were having this AI minus 1 minus AI plus A so this will be replaced by this term will be replaced by this, like this middle integer will be removed, so it will become just ai plus 1 minus a I minus 1. So we will just calculate the sum of the whole difference, and we will just remove the differences and change this difference to this. Like we will subtract this from the whole difference sum, and we will just add this and do check this for every I, which will be checked in O of 1 operation, and we will check for every I, so it will be O of 1 into O of n, which will be O of n. So this will become our O of n solution for this question. Let's move to the C. C was not pretty intuitive, or like it is not that straightforward. I also like this I will say that the C question is the toughest one in the whole context on a whole contest for me, because like this I have written like if we have any k and we want to check, so if any integer is below k, we cannot change it to any value, and if it is greater than k, we can only change it to 0 to ai minus k, or to itself only. So we will check this condition, and if it is verifying this condition that k will be true, and I still don't know that if a particular if it is possible for a particular k, it will be possible for the k less than it, but I think it will be, because as k will go down, it will be much easier for the integers which will be less than k. The main problem here is of the integer which are less than k. If we have no integer which is less than k, there will not be any problem. So that's why this is a binary search question. Then we can move to the D question. D was pretty easy, I would say. It is very intuitive. You have to just you have to maximize the number of set bit in the numbers. The highest number of set bit should be in P0, then P1, then P2, and their n should also be like their n should their n operation end operation should also be higher. So like if you see the video, you will understand how I approached this question, and it was like in the flow, I would say. Like firstly I wrote a solution which was not the correct one, then I looked in the solution, and then find out that there will be some numbers which will be overlapping to these numbers. Like we are moving from the all set 1 to 1 minus. I'm not able to explain this solution. So this is all from my side, and like I know I have not able to explain these solutions effectively or I don't know, but I tried my best, and you can look into my solution and how I build my intuition to solve this problem. You will understand if you know how these problem are solved. So that's all from my side. Still, the contest is remaining, but I will not solve any problem. I don't want to actually. So, bye.